Okay, let's have a look at 1373. Let's just pull this down a bit. So here we have a 0.8 megagram car, which we already know is 800 kilograms. It travels over a hill having the shape of a parabola. When the car is at point A, there's point A right there, it is traveling at 9 meters per second and increasing its speed at 3 meters per second squared. Increasing its speed, okay. Determine both the resultant normal force, and the resultant frictional force that all the wheels of the car exert on the road at this instant. Neglect the size of the car. Okay, well, let's just extract the information. We know that the mass is 800 kilograms. We know that at point A, we have the velocity of 9 meters per second and increasing its speed, which is AT, of 3 meters per second squared. Okay, then the question is what? Determine the normal force and determine the frictional force. Okay, so how are we going to do this? Well, the first thing obviously we need to do is we need to draw a free body diagram. Alright, and let's use some colors. So we know that at point A, right, the car is now there. It's at point A. There is a normal direction. And there is our tangential direction. Use your imagination because I can't really draw straight lines that well. Okay, so now, what do we have? I wonder if we can change color. Okay, now we're going to look at the forces. So that's our normal axis, that's our tangential axis. What is happening? Actually, you know what? I need to just redraw this. Sorry, it looks very bad. There's our lovely car, and there is our tangential axis. Okay, let's go back. Sorry for wasting your time. Okay, so let's just clean up that. So what are the forces acting on this car now? We know that we've got a normal force acting up. And what's the direction of our weight? Our weight, we've got our weight acting straight down. That's our mg. And then we've also got a frictional force, which is, of course, causing the car to actually move on the road. Right? There's a friction force acting on the car in this direction. So there's our F friction, here's our mg, and there's our normal force. Okay. So now what we're trying to do is we're trying to find what the friction force is and what the normal force is. So we know that we can sum the forces in the normal direction, sum the forces in the tangential, but we need some angles now. Okay? We need some angles. So if that is our horizontal, how are we going to find this angle here? But you'll see why we need some angles, because we're trying to find, you see, in the normal direction, well, let's just go write it out. Let's write it out. Sum of the forces in the normal direction is mv squared over rho. And we can take that down as positive, right? So what are the forces going to be? Can you see that this weight has both a component in the normal direction and it has a component in the tangential direction. So we need this angle, one of these angles, in order to decompose this force into its two components. The normal force is already in the normal direction and the frictional force is already in the tangential direction. So we don't need to decompose those, but we need to decompose this one. So we need some angle information. So how are we going to find this angle here? Well, the one way of doing it is we've got the slope, we've got the function here. Y is this. We've got this function. So what we can do is we can find dy dx. And dy dx, if you carry this out, is equal to minus 6.24 10 to the minus 3 x. Okay, if you take the first derivative of this, if you do dy dx, why do we want to do that? Because that gives us the slope. That gives us the slope at this point. Okay? The slope. And then we know what the x value is at point A. It's 80. So if I plug 80 into there, I end up with 0.5. So the slope of this function at point A is 0.5. That's the slope. What does that mean? It means that if I look at this, something like that, 0.5 means dy over dx. So you can see that dy is going to be half of dx. Okay? So that's my dy, that's my dx, and dy dx, the slope is 0.5. So if we want to find this angle, we can go tan to the minus 1 of 0.5. Remember, opposite, tan is opposite over adjacent, and theta is 26.56 degrees. Okay? So we've got this now. We've got that, 26.56 degrees. So that allows us then to calculate these angles. So this, because this is 90 degrees, this will then be 63.44. That again will be 26.56 and 63.44, etc. Okay? So now we've got our angles. Okay. So now, what are all the forces in the normal direction? We are going to have, we're going to have mg cos of 26.56. That gives us the mg component in the normal direction, and it's plus. Alright, and we're going to have minus the normal force is equal to mv squared over rho. Okay, are you happy with that? So the mass of the car is 800. 9.81 cos 26.56 minus the normal is equal to 800. The velocity or the speed at that time is 9, and we square it. And the rho, the radius is just calculated using that equation. Let me see. I don't have it in front of me, but you need to go back and figure out how to calculate this radius. It is 223.61 meters. It's that long equation with dy, 1 minus dy dx squared to the power of 3 over 2. I haven't memorized it, and I don't think you should either. Okay, but you just go and put in all that information, and you will get this. Okay, so we've got 223.61. Alright, guys, you better make sure you know how to calculate that radius, how to work that function, okay? Then the normal is calculated to be, I get minus 6729 Newton. All that means is it is 6729 Newton up. Okay? So it's the normal direction. It is the negative direction. That's the positive direction. Okay? Let me just get some white space here. Alright, what's next? What's next is some of the forces in the tangential direction is MAT, and again, we've got our friction force, but we've got this weight which contributes to what's happening in the tangential direction. So mg cos 63.44. So we've got mg cos 63.44 plus F friction is equal to MAT. Now, the important thing to note here is I'm not converting this into mu Sn. Don't do that, because it doesn't tell us anything about where the friction force is. Is it about to slip? It doesn't tell us that. It is friction force is just simply an unknown force that we're trying to calculate. All right, so that's 800, that's 9.81. M mass is 880 is 3. So you plug all that in and you get your friction force equal to 1109.1 Newton. Okay, that's my answers. Cheers.